just wanted to walk through one of these final problems here. We didn't quite get to that in class, but we did do that during lab. So we've got an example here where we're looking at SO2Cl2 and we're trying to minimize the formal charges. The idea here goes back to our exceptions to the octet rule. So this is one of these expanded valence shell molecules. We had some examples of that in lab, but just the idea here, if we're in the third period and lower on the periodic table, we can have more than 8 electrons around the central atom. That's because they have d orbitals available. Once you get down into the n equals 3 shell, there's a 3d orbital, and so you could potentially have 10 or 12 electrons around the central atom in certain cases. In general, how we'll deal with that is just if there are more than 8 electrons around that central atom for something like PF5 and SF6, we just, are stuck with that. In general, we can also have a case like this where we choose to violate the octet rule. So in this case, if we look at the Lewis structure that it gives us, we can see the formal charges again. A little bit of a bad habit maybe to click this on to see what the formal charges are, but you can see them when you do that. Sulfur brought 6 electrons, and if we draw our circle, it has 4. So it has a +2 formal charge. So we can lower sulfur's formal charge by forming some double bonds. Since sulfur is in the third row of our periodic table, that is sort of an acceptable thing to do. So that's the approach here. Since right now we have a formal charge of -1 on oxygen and +2 on sulfur, if we make a double bond here between O and S by going on to oxygen, taking a lone pair away, adding a bond to, oops, not an extra bond there, adding a bond here, that will now reduce the formal charge. Now sulfur is making 5 bonds. It brought 6, has 5, so it has a +1 formal charge. Oxygen brought 6, has 6. We've reduced its formal charge to 0. Similarly, we can go in with that other oxygen and do the same thing. Add a double bond and remove one of its lone pairs, and that will now get my oxygen to a formal charge of 0. Cl already has a formal charge of 0. This is the overall best Lewis structure according to the formal charge criteria because we have 0 formal charges on each atom. We can only do this since sulfur is in that third row or lower on the periodic table, but this should then give us the correct answer.